Let me start. Okay, hello everyone. Thank you for attending this. Oh, this just moved automatically. And thank you for attending this presentation. I am Esteban Maringolo, the other Esteban, the one that gets emails for Lorenzano pretty often. But I am a senior software developer at Authentications since like 5 years ago. And today I will continue talking about Unicode, but I will try to demonstrate just a simple application, as simple as it could get, showcasing the vast support of Unicode across the web, development tools, as well as the database layers, something commonly referred as a full stack thing, which is basically end-to-end support of Unicode. And to achieve this, we will first do a quick recap of the existing Unicode support in BAST and the abstraction we use, although you already had some answers from Henry. And then I will show the state of Unicode as per the latest release of this year. And finally, I will enable Unicode support at different layers for this demo. And we will see how the flow of Unicode content can be input, stored, retrieved, and displayed back, preserving Unicode strings or Unicode abstractions the whole way, and only using UTF for transmission and storage. So let's do the recap. You already heard Henry talking about this, but for those new or those that just arrived, basically, this is how we organize those are our main Unicode abstractions. We have the Unicode scalar, that is as Henry pointed out, it's the equivalent to we represent a code point. That's what you will find in the Unicode database, except for a restricted range that's used for UTF-16. Then we have the grapheme, which is like the main character here, and literally the main character because it's what the user perceives as a character. This is other implementations are code point based, so we can say that they are scalar based. Our implementation is grapheme based, and that's what basically what it's deleted when you press the back button, basically. And this is like, as I was saying, we have all the normalization built in. For instance, in the example above, when you have there, you can see that we have the E with a tilde that it gets clustered into a single grapheme. And then we have the Unicode string that is a collection of graphemes. One of the things that is different to the string implementation in older dialects and in VAST as well is that this is a growable collection. It's not mutable, so it's not that when we reach out certain size, we have to copy and extend it and become the new thing. Its API is largely compatible with the regular string. So for the most part, it will work just as a drop-in replacement, but there are some edge cases that it doesn't, and that's why we are actually rolling out Unicode support for many of our frameworks gradually. And one of the things that I think that Henry mentioned that as well is that Unicode strings are always, its internal storage is always UTF normalized and validated. So in this case, just following the example given before, if you reverse the Unicode string, you will get the flag, the E, and the A with this little, I don't know what's the name of the Armstrong, I think it is, on the top. And if you do that with many languages, not just other smaller dialects, you will get basically like the for the school, then the flag, then the tilde, then the E, and then the A. So basically, we preserve that in properly following the specification. And Unicode support was added to the core of VAST in 2022. This was version 11. And since then, we've been adding support to various libraries and frameworks. In our latest release this year, 2024, we included support for our entire set of libraries for database. Basically, all our database, all supported database driver now are Unicode ready, so you can use Unicode. That includes GLORP as well, so you can do ORM using the regular GLORP abstractions, and you can just drop in Unicode strings as with any other string. Regarding C side, we added support to render Unicode components. Actually, that was partly contributed one of our customers. However, in the current release, we didn't make it on time just to have it how we wanted to have. So you can render, you can output Unicode abstractions like grapheme, scalars, and Unicode strings, but you cannot take them as input. Basically, you cannot get a Unicode string as an input and then manipulate it. So basically, you cannot have like a special characters coming in a URL, even if it's UTF encoded, as long as they are not represented or they cannot be represented in the active code page. And as is usual with most of the features we roll out, Unicode support is optional. Again, existing users are not forced to adopt it, although we do encourage them to do so. And this is what's coming in the next version. Basically, we updated CSI and Grease to the very latest version on the GitHub repository. And just updating this wasn't, I mean, we added support of Unicode to C side, and it wasn't that straightforward as we had to change the way we hashed strings in the Unicode string. So this is like something that we had to do because we didn't want to modify the upstream code base just to deal with the quirks we had. So, I mean, the quirks were that they were not quirks, but Unicode strings hashed differently than regular code page dependent strings. And we now have a way to make them compatible, so you don't have to resort to a special class of dictionaries where you use a special common algorithm for both, which is something we had to do, for instance, for glorp and database. So now you can mix strings and Unicode strings in the same dictionary or any other hashed collection, and it will work just right away. And again, this enabling Unicode support at the C side as well as the database side is optional. Usually we have this common selector, it's like enable Unicode, and things just start outputting Unicode strings instead of just a regular code page dependent strings. And for the most cases, this is just for output, for input. Well, in the case of CSI, it's for input as well. But in other things, I mean, when you enable Unicode support, you still can take Unicode or regular code page dependent strings. I mean, you can take both. But when you have it disabled, you can only handle code page dependent strings. So I will do just a quick demo. This is a short and interactive thing. I wanted to build something that shows basically CSI, database, how we store it, and then how you can see that everything, all the Unicode components in our tools. And I will try to show you how it is. Let me just try to connect. How it works now that we don't have CSI support. Let me see here. Okay, let me just open Unicode support, sorry. Yeah. Let me just move it to, oh, here it is. Okay. This is a small tool that, oh, I don't have here, okay, that we are all going to access later if our network grants us access to it, because it's been unreliable, but let's hope it works. Basically, what we built is a Unicode lookup tool where you can just type anything, like any character. Well, you have some samples here, like, I don't know, cat face, and it will search in our, we ship with our product, we ship with a small database that contains all the code points and names and some other properties. So we have, with each scalar has a name. So in this case, I'm just searching the database. It's a sequential search of millions of characters. And here you get the actual code point in hexadecimal representation. And then you can see here, I can represent this smiling cat with a heart-shaped eyes. But if I try to access this, oh no, I'm just pointing to the wrong one. Yeah. And if I try to access this, you say not found. And why is that? Well, that's because I get this in the URL, but when it gets to C side, it tries to decode that UTF encoded unit, let's say, but it cannot map it to any code page character, I mean, any character in the active code page. So basically, we get the famous replacement character, the one that should be in We Love Unicode there. So let me show you the code. Let me just replicate the string. It's going to be simple. Otherwise, I will be looking back and forth. Do you see your screen? Yes. Okay, let me go here. Okay, I have it here. I don't know why I'm looking there. Okay, let me show you how it actually is. We have, as with any other CSI implementation, we have a codec. We have our own UTF-8 coder. And let's say I have a decode, just method. And you can see here, this is just says Unicode enable. I'm going to add a breakpoint here. And I'm going to reload this page so you can see what's going on inside. And basically what's, okay, this is breaking here. This is, can you read the code? Because, yes. Good. So Unicode is not enabled now, and I'm getting a byte array. It's just trying to parse the path here, the URL. And I'm going to just resume it just so I can get to the part that I'm interested with. The view, now we get the scalar, and now I get the actual parameter. And you can see here, I have the sequence of bytes that gets interpreted as a cat here. But when I try to decode that, because this is disabled, well, this is just trying to convert from the UTF-8 code page to the active code page. And if I inspect this, let me just select this. Okay. I get 2 replacement characters because it's like a 2-unit thing. So basically, I cannot take that input. I'm using emojis here because it's like the most complex thing that you can deal with, but it could be any character outside of your active code page, basically. It could be like Cyrillic character, Greek, or whatever language, Chinese, Japanese, or any other one. So this is, again, it's not going to work. So when it tries to build the URL here, if it continues to decode it, yes, we will continue to decode it. Let me just disable this breakpoint. And I will resume, of course. Then when it tries to get what I'm looking for, which is something that I just typed, it won't find it because basically I'm getting a replacement character. So what I'm going to do next is, I mean, again, here you can have, I mean, this is for you later if you want to use. This is something that we even use in CSI just to testing UTF encoding. You can just, this is a sampler thing. You copy text from here and you try to paste it here, and it won't work because, of course, you cannot match the thing. If I put an E with a tilde, it will match. And you can actually, you can see, because this is a single thing, this one is composed, it actually decomposed this thing into 2 elements, which is the letter E and the acute accent. And here you can copy different representations and such. So what I'm going to do now is to enable Unicode at the database, at the CSI level. It's here. No, it's here. This is where's my script manager here. And as I said, we're not only using CSI here, we're also using glorp just to store each search. So what I'm going to do, I will give you access to this in a moment. So if you have your phones ready, there's going to be a QR code on screen. And we'll try to make a ranking. So I will try to see what are the most searched characters, just basically for you to play with it. And what we did just to show, again, the very simple thing that we can store is we create a single entity in glorp that we map to a table that's in SQLite database. SQLite is UTF-8 by default, so that we don't have to configure anything special for it. And we have a mapping that's going to map everything. And every time you search for a particular thing, when there's a hit, that's going to be logged. And then we will make a ranking and see if some particular character was searched more than other. Hopefully some in your local language. This is good because it's a very international conference, so we will have different languages at use. I should show you that we have this entity. Well, this is not relevant for this. I will enable Unicode support here. What it means for those that know CSI, it's just we have the UTF-8 codec. You just enable Unicode there, and it will start producing Unicode strings. And for the database manager, it's the same thing. We just enable at the whole level and just resetting everything just to make it more clear. And now, if I reload this, not this one, let's go back to this, and I go to the cat face example I had before. You see here, it did work. Now I got the actual scalar or code point I was looking for. And the thing here is, okay, how it works. Again, let me just go to the codec here, and I will reactivate this one. You can see here, for instance, if I reload the page again, different searches for the same characters won't give you more ranking. I mean, it won't count as different hits. It will only count as one per IP address. So it's what's going to break. Here's my breakpoint. Again, this is parsing the URL. Here I have the Unicode thing. Again, this is the scalar parameter. This is the actual parameter. Here I have the thing. What it's going to do is it's going to decode that thing. It's going to repair it, because it could be the case that basically you're sending just garbage. In that case, if our Unicode strings, you have a way to enforce that they are always valid UTF-8 sequences. And if it's not, we have a policy just to repair that, which means that anything that cannot be decoded is going to be replaced by a replacement character, which is like the question marks that we are used to it. So here we have, again, the thing, but as you can see here, this is a Unicode string. And the Unicode string is composed of graphemes. And here I have the first element of the string, which is a grapheme that has a name, and we have some properties listed here. But the grapheme, we said, is composed of scalars. I'm using just a one-to-one-to-one example here because it's the simplest one. I can show you later if you want some more complex examples. And here we have the Unicode scalar, that is the actual thing that we're going to represent and the thing that we're going to store. So here's like, we're mapping that. And let's say we continue with the decoding of the URL. There's another field. No, oh, let me go. Oh, I messed it up. Oh, here it is. Oh. Okay, finish decoding. Yes, source. Okay. I swear this is the last one. Yes, it is. But for instance, the URL here, if you see like the path here, let me just inspect this one. Oh, no, this is not the actual path. No, it's with the field, sorry, the query fields is the thing I was looking for. You can see here, I can see the actual elements just using all the Unicode elements. So in this case, I have a Unicode string for this particular thing. It's not that I'm just mapping to some internal representation or anything. At this point, I'm just manipulating all our Unicode abstractions. And this thing is going to be there. It's the same result because I'm just reloaded the page. I will go into disable that breakpoint so it doesn't break again. And each time there's a search, I told you that we are creating a glorp object. I mean, it's a regular object that we are storing with glorp. I'm going to show you, for instance, in this particular thing. Let's say I created this object, which is the scalar search thing. I'm just going to read it. I have the replacement character. There was one thing that hit, and I have here like this. I have two searches for the cat with the hard eyes, and this is something that was just retrieved from the database. Actually, if I look in the database browser here and I reload it, oh, here you have here like the actual thing. We have this is just a mapping one-to-one. It's, again, really simple, just to show you how you can. You don't have to deal with any encoding or anything. All the rendering is going to be done by the rendering system. In this case, as Henry pointed out, if the character is not in your selected font, Windows itself is going to find the right font to render it. And in this case, for instance, if you see, I lost it, I think. No, I have it here. Like here, it's using a different font, which is another representation of the same thing using a different font. And this one, we're using, one thing that we didn't mention is that we use, in this case, is like accelerated writing when we render fonts. So it's actually, this is really performant. In this case, it's using the accelerated one. This one is not the one in the table view or the tree view. So just to let you play with it, I will continue with my presentation. And then let me just switch to extend. Hopefully I won't mess with anything else. Yes, okay, let me get back to this. So if you have your phones ready, well, this is, oh, no, you have phone ready, you won't see that. Let me just switch here and minimize this. Where's the screen? Where's the screen? Oh, it's here. Let me just move it here. Yeah, we should mind this here. Okay, it's like if you are connected to the INRIA network, I recommend this one because it's way faster. Because the other one, this one goes through the internet and gets back to my computer. It's using a tunnel. So, but hopefully you will be able to access it. If I, yeah, hold on. No, I won't move. I just give you, just trying to disable any remaining breakpoint. You will be connecting to my actual development machine. So, where's the? I'm missing. Oh, here it is. It's transcript. I will just doesn't work. This one. Yeah, oh, look, I just lost connection to the VPN. No one will work. Okay, hold on. It's just, I didn't check that. Yeah, hold on. I have it here. This is not part of the plan, but the thing is like there's much left. Okay. Just let me move this to my screen so I can type it faster. Ring one. I will let you access.
Yeah, looks like the Wi-Fi is gone.
The Wi-Fi is gone here? Okay.
You are gone? Okay.
Yeah. Oh, I am connected now. I am connected, and yes, now I think you will have to use the local IP version. Oh, it seems to be working. Yeah, no, it's actually the tunnel is working, so that's good. Okay. Okay, so you can access the thing. Well, you can play with it.
Can you show the QR code for 1 second more?
Yeah, sure. And just type whatever you find funny to search, or I want to see some creative characters showing up. Again, you have the sample there. I'm lost between the two screens, but here you have this, and if you access like let's say this one, well, I'm accessing from localhost, you have samplers here, you have the Salgo text generator. This is what, basically, let's say I put an A here, and it's generating some Salgo. If you type this in the lookup tool, like here, it's going to decompose that particular thing into all the scalars. So you can search for a particular one, or in this case, let's say okay, sorry. You missed that part. I was showing the Salgo text for this. If I type the Salgo text here for a single character, you're going to see the whole thing, like all the composing elements there, or even some emojis, like the family emoji. In Windows, you can have your own family emoji with different colors and different elements and whatever. This is not my family, but let's say you search for it and it's going to decompose. And we're using just vast elements just to decompose that, basically. And you hear, this is not the sequence in which the actual grapheme is created, but this is like different scalars that are part of it, like different skin colors, the boy, the girl, the man. But actually the family emoji is different things that get clustered as a single element. And it's like there's the boy, the girl, the man, the woman. They should cluster. If you use the zero width joiner, they will cluster as a single grapheme. And then you can type whatever you want as well. Let's say I'm just lost between the two screens. I open the boy. No, I'm just off by one. Hold on. The boy. Yeah, that one. Here you have the different things, and if you want to see any other properties, you can even click here, and you will see that this is all the properties that I'm not rendering all of that. Some of them actually require an external database just to look it up, but some properties like the one that Henry was mentioned, Some characters, they don't map one to one. I mean, just making as uppercase and then as lowercase is not something that's you can do forever. Sometimes you cannot, because if you're stuck in some point when there is no mapping from the uppercase version to the lowercase. For instance, one of the things that we had to deal with when we were migrating CSI as well, or some character encoders, is that when you do as uppercase and you have a character, you normally get a character back. In graphemes, when you do as uppercase, you can get either a grapheme or a Unicode string. So you have to take basically consideration for that. It's not that it's going to be impossible. Actually, it's pretty straightforward for the most part, but when you hit those things, then you have to, in particular, if we don't want to change like the upstream code base, we only want to modify what's specific for our platform, then we have to find ways around that. And that we did that to the extreme that we modified the hashing of Unicode string, because otherwise it will be really, really difficult to have support in C-side without modifying C-side code base itself. So now you can, I guess you have access to the QR. I will continue. You can still have access that. I'm lost again between the two screens. Okay. Let me here. I'm at the end. So what's going to be the Unicode support in VAST 2025, at least for the parts I showed up? Again, Unicode is optional. Glorp can take both strings and Unicode strings as input when Unicode support is enabled, and it's going to output Unicode strings instead of regular code page strings. And in C-side can take both strings and Unicode strings as input, and also we have Unicode support for the file libraries. We have a special way to represent that as ASCII text. We preserve the white spaces, so basically you can have a pretty much ASCII representation of whatever Unicode content you have that's text mimetype. And although this demo was small in scope, it demonstrates that in the next release of VAST, all of our users will be able to fully utilize Unicode when developing CSI or GREASE applications that also use databases. Or not, maybe you're just using CSI for a REST API that hits some other endpoint, but you will be able to manage or represent any character in the Unicode database. If you are an existing customer of VAST and you want to test this or actually have these applications, just reach out to me or to our customer support portal, and I will share this with you. So the story doesn't end here, of course. Okay, this QR code, I don't know if it's going to work, but let's just leave it there just in case. We have a lot of things in our roadmap when it comes to Unicode support. Collation is another huge chapter, because like sorting or collating is not the same. It's based on the locale, so it's not a property of the grapheme or the character itself. It's something else that you have to adhere to. Then we will continue with the Unicode integration into our own tools, like the MV library. The plan is to basically store all the code in UTF-8 in the library and because we have customers that have code page dependent strings, so basically have a way to have both and coexisting. In the browsers, the UI composers, then we will continue adding support. There was a question before about the file systems. Some file system can have different byte representations and even can have broken UTF-8, and we have to take that into account when we add support to file system support. SST libraries. SST is the server Smalltalk framework. It's a huge framework we have in VAST, supporting like remote code execution, remote objects, and HTTP servers, IMAP, MQTT, a lot of things. XML. And we are still deciding whether to have a Unicode string literal and a grapheme literal. We still haven't decided for anything. And for the most part, we're good without having one, but that's also something that we want to have that doesn't break and doesn't feel like too alien for what we as Smalltalks value. Okay, let's see how you play with this. Let me just get back to this. Hold on, I'm just lost again. I have time? Yes. No, if I go to here, maybe some of you already hit the ranking. Okay, this is what people search. This is funny. I hope that's not a qualification of the talk, but just like here you can see the logs. This is just using just glurp. I'm just reading from the database here. Let's see how many people actually search for this. Oh, a lot of people. Okay, good. Pile of poo. Yeah, actually, if you, I didn't think about doing that, but if you put poo here, see if there's another thing. No, it's harpoon. Yeah, it's just like, no, this is like a spoon. Okay. Yes. No, I can just put the full name and it will match. Okay. And then, yeah, this is maybe just a side effect of what I searched before. So let's get back to the demo. Minimize this. Okay. Here. And that concludes the presentation. I don't know if we have time for questions. Maybe there was some remaining questions that Henry didn't answer before. But if you have questions, I don't know if we have time. Now is the moment to do it. Otherwise, you can reach out to me or Henry or any other members of the instantiations team. Thank you.